Welcome back. This is the fourth video, and from the outline, we are supposed to do functions. Now, I was trying to prepare the video, and it's very hard. So it's very hard because in Rust, functions are intertwined with all the other concepts like variable, mutability, reference, borrow checkers. Everything is intertwined. And eventually, when you understand functions, you open up everything, you understand pretty much everything else. So, yeah, I was saying that usually the standard way to teach a programming language is you start with the hello world, variable, loops, function, this kind of stuff, and then in Rust it breaks because array loops are complex. We manage to do a simple one, but usually are complex. And functions variables are saying intervened. So I'm not the same that this problem, not only wanted this problem to try to explain functions in a simple way in Rust. So if you go into the Rust book, the problem is the same. So they introduce function, but they introduce very simple functions like this one. Just print. It's good, okay? This takes still print and takes two arguments. Or again function like this other one, this return an argument without even taking an argument. So if you go into this book, there will into this chapter there are not functions that takes an argument and return an argument. Maybe plus one. Maybe plus one. That's because the concept is very complex and we need to be it's very complex. So yeah, it's complex and intertwined with everything else. So let's try again to get into this. Um, So if there are problems, I mean, if you don't understand something, it means being wrong. So please, just what you do, you don't understand something, you say, hey, you just write a comment on the YouTube video, you write me on Twitter, you write this message on Twitter, you saw some email around, write it, use it. So if you don't understand something, just let me know because it's me explaining wrong. It's not you that really understand, you are dumb or whatever. It's just me explaining wrong. Again, so this part of the code is quite complex. And I'm trying again to do this video, no my first take. Yeah, let's do so cargo unit. We do like a particle simulation. So it's quite simple to understand in practice. This is a particle simulation. Let's see. Here we have our compiler. Cargo check. Is no error. Good. So particle simulation, we have a particle which has a position x x equal let's say 3.0 let y equal 1.0. These are position in some unit of space, and then this particle has velocity x, velocity of x, which is some velocity in some unit, some time unit over some space unit. Very well, but we don't care really. Nice, we have this particle which has its position, x and y, and its velocity. Good. Now we want to simulate what happened to the particle after 10 unit of time. So what happened to the particle is very simple. The x is increasing, and any unit of time, x is increasing by the velocity of x. Similarly, the y is increasing by the velocity of the y. And finally, we print it. We print our particle with this coordinate. Very good. Very simple code, very understandable. Nothing to be scared of. Let's run it. Oh, I always forget. For in good. So first problem. The variable are not mutable. So in Rust, if you declare a variable like this one, here, let, without nothing, is immutable, so you cannot change it. So we did this twice. We declare x as mutable, and then we try to change it. This is not allowed, but it's easy to fix. The compiler also tell you, make this binding mutable y. Good. Let's do that for both x and y. Very good. Let's compile again. It's running. Let's spit out some number that makes roughly sense. 20, which is 2 by 10 plus 3, 23, and 1. 1. Is something wrong? 31. Oh, what is 3 times 10, 30 plus 1. Okay, good. Now we are not savage. So what we try to do at this point is to, and it will be a big error, to describe our particle with what is called a struct. So we put everything into unstruct, define a particle. We need an answer y, after 2, and after 2. Similarly, we want to describe the velocity as a vector that has the same property. So this is you declare it, and if you want to make one, let p as a particle is equal to particle, and then the number you want, 10.0, 1.0. This is very simple. And now let's do also the same for the velocity. So 2.0 and 3.0. So we are saying here, let note, because we are going to mutate the particle, p dot 0 describes the first value, p dot 0 the first value is equal to p dot 0 plus the value plus b dot 0, p dot 1 sometimes before. Let's run it. Oh, we need to paint a particle. Okay. Dot 0, p dot 1. Let's save it. Let's set it down. Good. Same result before because it's simple. We don't expect anything. Good. So now we try to define a function. What is a function? A function takes some input and spits out some output. And I mean, the first time you see functions, the first time you code, you want, I mean, let's do it. It's just a function that updates state. And what we need is function in the particle p, update, and the velocity. And what does this function return? It's supposed to return a particle. Let's make it return a particle. So what it does is take a particle and velocity, put them together, and return a new particle. Good. So it's quite simple. So let the particle, let here p dot 0 plus p dot 0 plus before p dot 1 plus p dot 1. Actually, you can just do it like this. Good. So let's try to let p equal update state of p and v. See what happens with this. Good. Check. Very velvet. So if you start from the beginning, and use a variable p, which is this one. It's gonna in a second. Then remove this mute. This particle here is not used. And then what is worrying is here. Use a movie value v. Value movie here in previous interaction of the loop. So we already see that something is wrong. It's talking about previous iteration of the loop. Let's try to remove the loop. So we can do something like this: p1, p2, p, and p1. So instead of doing a loop, we just unroll the loop ourselves. Let's see what happens in this case. Similar problem. Move occur because of v, step velocity, we just don't implement the copy trait, we don't consider about this one. So value move here, value is here after move, so we move the value inside here and then we use it after move here. Now, the aha moment in Rust happens when you understand that if you pass something like value, like in this case, you pass the velocity like value, you pass just the velocity, that is lost. I mean, you are not going to recover it. You are not going to get it back in some way. So usually normal C, Python, C++, Java, whatever. You pass this, and then after, like here, in this part here, in normal languages, you can again use B. For whatever reason, you can again use it. Just now, that's not work like that. If you pass it by value, then the function evaluate get it. You will never get it back. Yeah, that's the very first problem. And this problem is made worse by how user code is written, because we just not implement the copy trait. Most stuff you should implement the copy trait. Most stuff, normal stuff, you should implement the copy trait. So you don't see this problem immediately until it does not eat you like real with memory problems. Like, why I cannot move strings? Why it does not work with string or just with number? Because number implement the copy trait. And this is the reason why we do this struct instead of using raw numbers. So there are two ways to reason with that and to fix the problem. One, first of all, free way. Well, very simple one, we just implement the copy trait for velocity, but we don't want to do that yet because we are not sure to understand what is the copy trait yet. The second one is your reference. Then again, we are not sure what's our reference, we didn't use them reference, we're not going to use them. And the last one is to get an EV. So what if instead of a particle, we return a particle and a velocity like this. So this is the particle as V, and then P1 with status 1, we should not use it anymore, and then P equals status 1 dot 0 particle, and the velocity is equal to status 1 dot 1. Good. Now we are in this, and this will be status 2, where P is going to be equal to status 1 dot 0, the status 2 dot 0, and V is going to be equal to status 2 dot 1, and then we can do the P as we define, and then will be the same from before because we are changing the value P and V, so this needs to be mutable. boom. Let's see what's happening in this case. Bias to V is never used, okay, we never use this value, but because we don't print it. But it's actually working. So I hope I convince you. What is happening is that update state return a tuple to element, just like particle velocity, and then we change this value here. And we assign, and we can use the same update statement. Good. If you understand that, you can do the same work inside the loop. Before in 0, 10. Boom, it's working perfectly as usual. So but now please understand that as long as the velocity, which is very simple, very small, is not a problem to return it, but oftentimes it is filled. I mean, oftentimes you need to pass a lot of argument and you cannot just do this several times over and over again, like decompose the tuple several times. Like maybe you have an acceleration, maybe you have a magnetic field, or the stuff cannot go together and then can be returned. So we need a smarter way to do it. And the smarter way we see will be a combination of the copy trait, so understand what is happening, and the user reference. That will be the argument. Some of them will be the argument in the next videos. So yet again, uh, this video, I mean, it seems stupid, but it's really a cornerstone of understanding Rust. If you understand this video, I mean, you're much farther than you will. In general, you're much farther than understand borrow checkers. Yes, so if you have questions, please let me know. Yeah, just comment. And that's it. If you want to know when will be the next video, you follow me on Twitter or YouTube or yeah, pretty much that. Okay. Thank you for watching. Yes, again, if you have questions, just let me know. Bye bye.